So, guys, we are starting the last chapter.
Yay! We made it.
Yay! Can you believe it? Can you believe it? I can't believe it. All right, so chapter 10, this is the chapter we kind of flip-flopped order. We have actually thrown in some vocabulary in chapter 11 with chapter 10, so you'll see that another lesson. But the first section of most chapters is a lot of just kind of introductory stuff. This one is no different. A lot of vocabulary. Okay, so this is just getting comfortable with the vocabulary and then applying it to some scenarios. Okay.
All right.
Notice chapter 10 is all about circles. We've talked about circles throughout this chapter, just not in great detail like we're going to do. Okay. And I'll tell you, there are things in this chapter that math teachers at the high school say that this is a really big concept on ACT. So we've heard that. So this is stuff,
You're going to learn more about circles than you ever thought you would care to know before.
And we want to make sure we understand it, okay? So, section 10.1 is talking about this idea of a tangent to a circle. That's going to be our main focus. We are dividing this section in 2 days because of the fact that there's lots of vocab and some theorems. So, we'll talk about the vocab today. Whoops, sorry, guys. And then tomorrow, you're going to see the theorems, okay? So, vocabulary. First of all, what exactly is a circle? I think this is kind of a hard definition. It says it's the set of all points in a plane that are equidistant from a given point. So these are all points that in a plane. So a plane is two-dimensional, and it's equidistant from a given point. Now, what do we call that given point?
That's the center of our circle.
All
And
right.
think about it, if I had a piece of string and I held a piece of string in one point and I just drew every single point around there. You guys have this thing called a compass where it keeps that equidistance. And if I put that point of my compass in one spot and I draw all of the points that are equidistant, that's what makes up your circle. That's kind of the idea of a compass.
Now, Ms. Kirby, you gave the same description with a sphere. So what makes this different?
Because in a sphere, it was in all directions.
Good deal.
Where
Just
this
wanted
is
to
just a
clarify, make sure
two-dimensional
you're
shape.
good with that. And I'm like, I remember you saying this. Maybe you do too. All right. So a radius. We've talked about radius again. This is good. We're going to go through this kind of quickly. Radii is the plural, not radiuses. It's the distance from the center to a point on the circle. Okay. So point on the center to a point that's on the circle. Right. It is a segment. Okay. Stressing that. All right. The diameter is basically the distance across the circle through its center, and is also a segment. All right, so again, distance across the circle through its center. So that basically means, because it's a segment, what are the endpoints? Where are the endpoints located?
The endpoints of a diameter would both be on the circle,
Okay.
but it has to contain the center as part of that segment.
Exactly, because you're going to hear this distance kind of across the circle again, but it doesn't have to go through the center. We'll see that in just a minute. There's such thing as congruent circles. These are circles that have to have the same radius.
Which would make sense because if they have the same radius, then any formula that I would look at when I compare their areas or their circumferences, they're all going to be the same because they have that same radius measure.
And radius is kind of the key, because when we find the area, pi r squared, circumference 2 pi r, diameter and radius, we know there's a relationship between it. Again, a lot of stuff we've talked about before, so I don't want to bore you too much.
All right.
All right.
So we're going to go ahead and just draw these on the circle real quick.
All right, so radius, first of all, this is the center. And a lot of times when you name a circle, you name it by its center. So what do you want to name this circle?
I think we're going to call it circle H.
H? Okay. So it's always a capital letter because of the fact that it's a point. So we call this circle, if I can spell, circle H, or you'll see a circle drawn. We've talked about this before,
Yeah.
H. Now,
Make sure you put that point in your circles. That way it's not a zero.
Okay, so radius was one thing we drew. So it's a segment, goes from the center to a point on the circle. So this would be our radius. All right. And what's another thing we had?
Talked about the diameter.
Diameter. Now, diameter has to go through the center
But
and has one vertex, or one point, not vertex, point on the circle as well as another point. So I'm going to draw it like this.
Love it.
And you could have drawn it, you could have extended out another radius. So this is the diameter. Okay.
All right.
Let's talk about some more vocabulary. And we're going to go back to this picture, guys. Okay?
All right. The next things we're going to be talking about, we have a chord. Now, these are new words that you probably haven't seen before. A chord, it's a segment whose end points are points on the circle. We just saw a definition that talked about endpoints being on the circle. What definition did we just refer to?
A diameter.
So what's different about the chord? What does this not have that the diameter did have?
Well, wouldn't a diameter be a type of a chord then?
Diameter is a type of a chord.
So a chord just doesn't have to go through the center.
All right.
But
so
if it does, then it would be considered a diameter.
Right. So we'd always go with the most specific name.
Exactly.
So don't try to call a diameter a chord. We're going to call it the diameter if we know it is. But this would be connecting any two endpoints being on the circle.
Okay.
It doesn't have to contain the center.
And I like what she said, guys. When you want to be as specific as possible. So yes, a diameter is a chord. It's just the more specific terminology we use is diameter.
Right. There's lots of chords you could have within a circle. Now, a secant line, this is something kind of new. A secant is a line that intersects a circle in 2 points. I want you to think about that. It intersects a circle in 2 points, but it's a line that's not just a segment. So no endpoints here. So where would an example of a secant line be?
Well, a secant line, you would just basically draw a line that would have to go through the circle, right?
Yeah. Does it have to contain any other specific points?
It has to intersect the circle at 2 points. So it does have to have 2 points on the circle. It doesn't have to go through the center or anything like that.
Right.
But it does have to intersect the circle at 2 points. So that would be a secant.
So it's almost like we're taking a chord and then extending it to make a line.
So a chord would be part of a secant.
Absolutely.
So, and something, guys, this is all back to chapter 1. Remember when we talked about lines, segments, points? Lines contain segments. They contain rays. So if you're talking about characteristics of a secant, chords can have some similarity features too. Okay.
Yes. All right, next thing, a tangent. A tangent is another line, that's important, in the plane of a circle that intersects the circle in exactly 1 point. All right, so here we had a secant that intersected a circle in 2 points. A tangent only intersects at 1 point,
Okay.
but it is a line also. Oops, sorry, wrong direction. So when I'm drawing in a tangent line, I want it to be a line that touches my circle only one place.
Okay.
Okay? Notice that it doesn't cross through twice. This is the difference between a tangent and a secant.
Okay. That makes sense.
All right?
Now, can you have a line that intersects a circle like 3 different points?
Well, could you? Could a straight line do that?
No.
No.
So either 1 or 2, or a line may not ever intersect.
Right.
Possibly.
But then it wouldn't necessarily have a special name. that we would
Exactly.
use. Okay? The point of tangency is the point where your tangent line intersects the circle. Kind of makes sense. So if this is my tangent line, this point that I drew right here, that is my point of tangency.
That makes sense. Again, this vocabulary is important, guys, because we're going to be using it in some new theorems, new concepts. So just get comfortable, these words, okay?
We would like to see you draw this picture on your notes.
Yeah,
by the way.
hopefully you've been doing that.
All right.
All right, some more vocabulary. So here's it. We've talked about just one circle and, lines or segments intersecting it. 2 circles can intersect as well. And you can see it happen either with 2 points. Okay, here's a scenario where 2 circles intersect at 2 points. Here's 1 point. Here's the second. They could intersect at 1 point. So right there. But they might not ever intersect. So obviously these aren't intersecting. But like if you have a circle inside of another circle, that's a pretty common kind of geometric shape that you'll see. Then they're never going to have a common point. Okay. Now, what we call some of these types of circles, one example is a tangent circle. Now, think about looking at these examples, or even down here, do we see any circles that would be considered tangent? Now, think about the word tangent we talked about. It was a line that intersected a circle at 1 point. Now, apply that. These are circles, coplanar circles, so they're in the same plane, that intersect at 1 point. All right?
Okay.
So, would this be an example of tangent circles?
Absolutely, because they intersected at 1 point.
Mhm. And then down below, there's some tangent circles.
Right.
They intersect at 1 point. You could have a circle, like you could have a circle and then a circle inside of it. That's a tangent circles as well.
As long as they only intersect at 1 point.
Exactly. Now, concentric circles are actually coplanar circles again, and they have a common center. All right, what does that mean?
It means that the center of one circle is also the center of the other circle.
Exactly. So this would be an example of concentric circles. Now, what about up here? Would these be?
No, not quite, because I
Yeah.
can tell that the center of that smaller circle is not in the center of that larger circle.
So concentrics are, and I actually have a piece of artwork at my house that there's just a bunch of pictures of concentric circles. So they're used in even art out there. So bullseyes, when you play darts, they're concentric circles, things like that. Like the Target symbol, Target at the actual store. I go there way too often. It's concentric circles.
All right. Common tangents. So we've talked about lines that are tangents to a circle. And a common tangent is when we've got a line or a segment, because we could talk about a common tangent segment.
Yeah, because line contains segments.
Exactly. That is tangent to two coplanar circles. So two circles that are in the same plane. If you look at these two circles, they share one tangent that is considered a common tangent because it's a tangent to both of those that's drawn on this picture.
Okay.
There are other tangents that could be common tangents to those two circles. This is one example of a common tangent. Okay, it's tangent to both circles in the same plane. Now, when we're talking about common tangents, we could have these things called internal tangents or external tangents.
Okay.
All right, and here's the difference. Internal tangents, the formal definition says that it intersects the segment that joins the centers of the two circles. Now, to me, I don't love the definition as much as the way that I'll explain it in a minute. But this is saying that if I drew in the center of those two circles and I drew a segment that contained those two centers, a common internal tangent will intersect that segment.
Okay.
Okay? So I'm thinking about if I drew a tangent line here that goes through the point where those two circles are tangent to one another, that's an internal tangent. Okay? A common external tangent does not intersect the segment that joins the center of those two circles. We talked about this blue line out here being a tangent to the circles. Notice that this blue line does not intersect the segment that I've drawn. That's a common external tangent.
Okay.
Now, here's the way I like to think about it. If it's internal, it's going in between the circles.
Okay.
Okay? Now, chances are it could touch both of them at the same point, at the same time. Or it could, if those circles were separated a little bit, be a tangent circle. Oh, well, if I could actually draw where it's going to touch it, that will imagine that's a straight line and that it's beautiful picture here. But that's a common internal tangent. It goes in between the two circles and it touches each of those circles at only one spot.
Okay.
Okay? An external tangent will always be outside of the two circles.
Okay.
It won't go between the circles.
Gotcha.
That's going to be what I would refer to as a difference.
Now, will all circles have common tangents always?
There should be some form of a common tangent in coplanar circles in one. Well, I guess not always, because if something's totally inside of another circle.
Yeah, like concentric.
Yeah, let's think about that.
Go back
for a
at
second.
that slide. Go back a slide real quick. Like those concentric circles.
Yeah, if I think about a common tangent to this circle, it's never going to be a common tangent
It'd be a
to that.
secant to the other one.
Yeah. So circles that are not overlapping, there's definitely going to be.
So as long as the one is not now, if it is inside of it, as long as they are tangent circles, then they would have a common tangent.
Yeah, so down here you drew an example of common tangent circles. They do have a tangent line, and that's actually an external tangent.
Gotcha.
Okay.
All right. So here on this slide, guys, we have two scenarios, and we want you to actually decide what's going on. Okay, these are both we've drawn in the common tangents. Decide if they're common internal or common external. Okay, so here's the deal. Why are they, first of all, common tangents? Let's make sure we're good with that.
Because those two lines both only touch the circles at one point.
And they're tangent to both of them. The key here is they're tangent, so you explain that, and
But it has to be to
common
both.
because they're on both circles. So what would these two be?
Those are both internal tangents because
Okay.
they're going in between those two circles.
I'm going to put just common internal. I want to make sure that we know that these are common tangents as well.
Yes.
All right, now what about this one? These are common.
Those are common external tangents.
Now, this is actually, guys, if you're noticing, these circles up here are just kind of a copy and paste of these. So this, if you drew in all of them in one, you'd basically have these tangents here, these internal, and these external. Well, these are not the best drawing. Okay.
I feel your pain.
So this picture technically has 4 common tangents. There's 2 internal and 2 external. I know in your classwork tomorrow, you're going to see some examples where they're going to say how many common tangents. So be specific of what's what and how many, okay?
All right, so move into some examples. The first one says, name the type of each segment or line. So we want to decide, thinking about the vocabulary that we've learned, what vocabulary word best describes these.
And I like that you said the best, because
Yes.
there could be multiple things, but thinking about what's the best scenario. Okay, so I'm looking at line AH.
Now, the fact that it's a line already eliminates some options.
Yeah, none of them, like radius couldn't be one because it has to be a segment.
Right.
Diameter has to be a segment. Chord has to be a segment. So that, to me, looks like a tangent line because it's intersecting at point B, so that would be a tangent. And point B, just to kind of go off of that, that's the point of tangency.
Love it. Okay, segment EI.
Okay, so
it's a segment.
Okay, so going from E to I, and it is the center C.
The center
okay.
is C.
So that
Usually
would
we
make
describe that in this
exactly.
practice.
And the way to know it, guys, they would say this is circle C.
Right.
Okay, so that's a diameter because it's going through the center.
Love it. Okay, what about segment DF?
That would be just a chord.
Right, because it has 2 endpoints. It doesn't go on.
Now, technically, guys, again, because it intersects a circle at 2 points, you could say that's a secant, but because we're just talking about segment, we're going to be as specific as possible because it's a chord.
Right. If it said line DF,
It would be different.
it'd be different. Okay, what about segment CE?
Well, that would be a radius.
Right. The only one that does not have 2 points, or have both of its points
On the circle.
Okay. What about line HG?
Okay, well, I would think, it's going through the circle at 2 points, so that would be a secant.
Absolutely.
Now, notice you can't even consider this as a chord because it's not a segment. So keep that in mind. Yes, it's going to go through the circle at 2 points. That's what a secant is. But a chord of, what would be the chord of line HG?
Segment JE.
Yeah, and which is not even extended out.
Right.
All right, last example. All right, it says, give the center and radius of each circle. All right, so let's first name the circles. So what are the 2 circles we have?
We've got circle A, and we've got circle B.
And that's way we can talk about what's what, all right, because there's 2 scenarios. Now, when it says give the center, that doesn't mean, the center for circle A is A.
Right. On a coordinate plane, we know they're referring to the point
Okay.
A where its location.
So let's talk about the location, okay? And I like that you said location for the center for circle A.
So that is at 3, 3,
All right, and then let's go ahead and do the center for circle B.
which is at 3, -3.
All right, so that's one piece. Now we need to find the radius of each circle. Now the radius, we know by definition, is basically the distance or segment from the center to a point on the circle. So we could draw anywhere. Now let's make it easy for ourselves.
Yeah, I'm
All right?
thinking either a horizontal or a vertical.
Exactly.
Sounds good.
So if I start at the center here and I could get it go straight to here, this would be easy to count. So 1,
Right.
2, 3. So the radius would be
3 units.
3 units, right? And this would be,
Also 3 units.
so what does that mean about these 2 circles?
They are congruent circles.
So I'm going to make a little note. These are congruent circles because why?
Because they have the same radius.
Good deal. Now, I know that didn't say that, but you never know. You might be asked that question like that. All right, the next one, here's the deal. Part B has lots of stuff going on. And this is a question that's kind of easy to make mistakes on because there's so many different things. And it refers to some things from Algebra 1. These would be a great test or quiz question. Just a little
Hint,
hint.
hint.
Okay. It says describe the intersection of the 2 circles. So that's the first thing we're going to do. And I'm going to bypass this for just a second. So the first thing we're going to do is describe the intersection of the 2 circles. So first of all, they're telling you the circles are intersecting, right?
Right, which we can see that too.
Okay.
And I noticed that those 2 circles intersect at a point.
At a point. Now, when they say describe, what do you think we're wanting?
probably to give the coordinates of that point.
Exactly. So they are intersecting. So these circles are intersecting
At the point 3, 0.
All right, so be specific. So telling me where you're intersecting. All right, now the second part to part B, it says describe again all common tangents. So any common tangent that could be drawn in this picture.
Right.
Right?
Which they have given us one. Okay?
Okay.
They've drawn in that red line that I see there is definitely tangent to both circles.
And if you
But we need to
notice,
get-
why are they tangent?
Because they're intersecting both circles at just one point.
So when I'm asking for describing the common tangent, what kind of things do you think I'm looking for?
Well, I've got a line drawn on a coordinate plane. I'm guessing they're going to want the equation of that line.
Okay, so let me make a little side note. So when we describe, you're gonna tell me the equation, and because we're talking about common tangents, probably need to tell me what the type is.
So if it's internal or external.
So internal or external. Okay, so let's start with that red one since you're kind of pointed that out.
Okay.
Okay. Now, is this going to be a common internal or external?
That's external. It's outside of the two circles.
So we have an external one,
not between them.
and the equation.
Now, I'm thinking back to like Hoy and Vux because that is definitely a vertical line. So I know that the equation is going to be x equals some number. And I noticed that it's crossing through the x value of 6, so x equals 6 would be the equation of that line.
Good deal. Okay.
All right, now I'm looking for other common tangents that would exist. And I
Okay.
noticed that y-axis is another common tangent.
And I'm just going to highlight that a little bit more. Because, again, it's intersecting the circle, both circles,
at just one
at
spot.
one point. All right?
So where I've got external, I've got x equals 6. Let's just write in the other common external tangent.
These are both external.
Right.
Okay. So this would be,
That would be the line x equals 0.
and that's because it's still vertical and it crosses at the 0. X equals 0. Now, if you just said y-axis, well, that's not the equation. So we're looking for more specific, okay? Now, do you see any other external ones?
No other external.
And usually you're only going to see 2, the max, okay? Do we have any internal?
There is one internal. I look at the x-axis,
Okay.
and that x-axis is really only touching each of those circles at that one point.
Yeah, because here's the deal. Since these circles are tangent circles to begin with, they're going to have a common internal tangent, basically.
It's just, it goes through that one point.
All right, so this
So-
is the internal, and what's the equation for it?
Because that's a horizontal line, I'm thinking Hoy. So I know the equation is going to be y equals some number. And it's going to be y equals 0 because it goes through the y value of 0.